let's continue. I'm very, very happy to introduce the next speaker, Marcin Ignac from London. Marcin is not a scientist, and I'm quite sure he doesn't know anything about chemical engineering. So you are probably wondering why he's given his presentation. Marcin uses big data, like some of us do, but Marcin is an artist, a programmer, a designer. Now, let's discover his passion. Marcin, thank you for accepting my invitation. The floor is yours.
Okay. Hello, everybody. Yes, my name is Marcin Ignac, and I'm very happy to be here, even as we just heard, it's a bit out of my usual context, but I think what I'm trying to achieve here today is give you a bit different perspective how to look at data and how the data influences our lives. So let me just share my screen. Okay. So, okay, you can see that, right? The slide. Okay, cool.
Yeah.
Yeah. Okay, so I call myself data artist, and what that means is I use data as a source material for making art. And at the same time, I'm a computational designer, which means I use computation and algorithms to solve design problems and design challenges. And I'm originally from Poland, where I studied computer science, and then I moved to Denmark, where I studied interaction design. And now I live in London, where I run my own studio called Variable. And at Variable, we aim to challenge and imagine new ways of experiencing data or interacting with data. So if you think of, what is data? You can say it's a set of qualitative or quantitative variables, and probably the most of the time when we interact with data, it's through a database or a spreadsheet in very raw form, where there is not much information, like understanding yet. It's just raw numbers or raw values. So what we're really interested in is transforming data into information and then using that information to enhance our knowledge and our decision making. So if you're lucky, we can experience the data in a visual form via maps, charts, or graphs, and so on. And if you're even more lucky, we can interact with data via tools or interfaces that allows us to explore, like here, where we took a list, like a black and white list of grants from UK government, and made this interactive graph where we can explore which universities collaborate with which companies, like Rolls-Royce, for example, here, on what type of projects, in which areas of science. And this was, just another way to looking at the same data, kind of unlocking the potential that is left in the data set. So I like to say that, we think of data that can be experienced and not only counted. And this is kind of like the essence of this presentation here. So at Variable, we blend the design and software and the aesthetics emerging from data and processes and human behavior. And what that means is that we use the technology and art and design to reinterpret the data that can come from APIs or sensors or human behavior or software or natural processes, and try to visualize it and bring it to life. So first theme of a couple of projects I'll introduce is what I call the shape of data, and in particular, Algorithmic Skin. And Algorithmic Skin is like this software layer that enhances and constantly interprets our life as we move on. And one example of such thing is, smart wristbands or smart watches nowadays. And back in the day, we worked with Nike on this Fuel Band project, which is like a bracelet that counts how many steps and how many moves you did during the day, and you earn those fuel points. So what happens is that if you look at your week of activity, you can see clearly, where was the spike of activity when the given person had a training session or a run, and when this person was sleeping, and so on. And our task was to create a kind of an award or a sculpture made out of data that would somehow represent the effort of that person put into preparing for a night for a run. So if you think about a day, a 24-hour clock, and we start plotting those activity points throughout the day, you can see that, okay, that person didn't do much in the morning, and then, the major activity was about early evening, and then maybe they went for a walk late in the night to see the stars or something in that particular case. And now, if you imagine taking that circle and kind of counting those points or those activities as they happen throughout the day, and extruding like a branch almost towards you or on the z-axis, you would create a kind of a line, right? That would show the accumulative amount of points that this person collected throughout the day. And then you do it for every day, the week, and you get 7 those threads or branches. And actually in this project, we call them fibers. In a moment, I will explain why. And you get this unique sculpture of activity of this person's physical activity throughout the week. So we did this for 7 female runners for Nike. And, we experimented with different styles and, typical kind of artistic process where you have an idea of, or more of a feeling where you want to go, but you don't know where you will end up because you aim to create something new and not to the spec, not very specific. You want to explore. So we always look for inspiration. So in case of Nike, we look for, what kind of materials they are using, or, what kind of colors they are using, or what is exercise, what is exercise causing, right? Like, okay, it activates your muscles, and throughout, sustained exercise, hopefully you make them grow. So like the shape of the muscle fibers was also an inspiration, and hence the name of the project, just called Fibers. And even for colors, as an artist, you might assume that, I know everything about color theory and so on, and that could be further from truth. So quite a lot of times I'm cheating, where in this case, I took the picture of Nike apparel or gear for women for running, and I extracted the color palette automatically by computer vision to give me a color palette that then I use to customize those data sculpture for each person. And the final result was the seven images, unique per each person, completely driven by data, that kind of represented the effort they put into the preparation for the race. So that's one way of looking. What is the shape of data? Another way to look at data is data as a place, something like a place I would like to visit or go in there and be immersed in the data. This is a personal project where I look at Dropbox, which is a file sharing or backup service, where I have lots of folders, lots of files. And I have looked at what kind of files are contained there, and I have images, code, text, videos, and so on. And then I took this whole list of files from my Dropbox, couple of thousand files, and I made it almost like a spiral timeline in 3D space. So, which allowed me to fly through those files and fly through those files. And this is a very short, like 1 week project, but you could imagine that once we out there in the space, you would like to investigate or click this and that and see which files were actually hidden behind those simplified representations. And that brings the kind of term of synesthesia, which is like having experience of a feeling or a sense triggered by something unrelated. So for example, you can like smell music or taste the color and so on. And that's something I like to think about in my work, where we use shapes. Like for example, here I have this generative parametric system that can change its frequency or color. And the meaning of this behavior is very much kind of intuitive, right? So we used it to visualize the health of your heart based on your heartbeat, sustained heartbeat monitoring. So when we designed the system in a way that depending on your heart rate, it will change the color and the frequency. And then if you have some kind of arrhythmia detected, we designed algorithms in collaboration with doctors, the shape would become unstable and wobbly. And even though we don't assign a particular number that means that exactly that thing is happening at this given time, like just by looking at it and obviously having a legend for colors and so on, it gives you an intuitive understanding if the system, or in this case your heart, is stable and healthy, or is it unstable and unhealthy. And another kind of science-related project we did with Queen Mary University in London and artist Julie Freeman, and it was about monitoring a colony of naked mole rats, where we have RFID gate sensors throughout this tube system where they live, and we are able to track their movements. And these are very cool creatures because they have the same kind of social structure like bees. So there's a queen and worker individuals and cleaners and so on. Super cool. Yeah, and very ugly as well. So what happened is we track this data, how they walk, and we build this state machine where we know if a mole rat is walking forward or backwards, or is it eating, biting, sniffing, and so on. So by looking at those sensor readings and through also manual observation, we are able to build a state graph where a mole rat was biting something, and then it walked backwards, and then it walked forward again, and then it made another bite, and then it sniffed it, and then it sniffed it again, and then it decided to eat something. And this kind of graph, in computer science is called a state machine or state graph. But you can also compare it, it's a graph of a behavior of a mole rat that describes an action of an individual. But when I first, achieved the visualization on the left, like what connection happened in my head was, oh, this looks like a 10 steps diagram where you can imagine almost impersonating a mole rat and then role playing by following the arrows in the diagram and do almost like a mole rat dance on the stage that replicates the behavior of that individual. And of course, we had like a more accurate quantitative set of visualizations that will describe the activity of every individual, like which part of the dungeon, so to say, they favorite and so on. And that could allow you to identify, are there more like cleaners or workers, or is it a queen which moves the most, and so on. And yeah. So what is it really like? Is it data art, or as a fellow artist Memo Acton calls it, is it like a data dramatization, where we try to make impact, a kind of blown up impact on the visitor or the viewer, that it's beyond what the significance of the data itself. So it's kind of like almost like a negative description of what's happening here. Or as Tom Corby in one of his talks said, it's almost opposite of visualization. So when he meant like an accurate scientific visualization, and he coined this term un-visualization, where we focus on the experience or the vague and not on the precise or kind of numerical. And the way I like to describe what's happening here is like, what we basically build is we build visual representations of the underlying systems, and like a mole rat or heartbeat rate or exercise schedule and so on. So in my work, I'm interested in building systems and deconstructing them. So you build a generative or visual system based on data, but at the same time, you take a real world system like a society or the colony of mole rats, and you try to deconstruct it into smaller, almost algorithmic behaviors that can be encoded in code or algorithms. But what happens here is that, especially if you work with big data, like in this project for Google, where we look at almost 1 billion active Android users at that time, a few years ago. And we designed a set of tools that allows us to visualize this data, and each color represents like how big is your device, or how new is the processor, and how expensive was the phone. What happens is that, we took this raw data without thinking too much, what is behind those numbers, who are those people with those phones, and this was very much a data dramatization, where we wanted to show, oh, there's so many Android phones, and they form this huge kind of ecosystem of mobile users around the world, which clearly can tell you. You can immediately see, where is the biggest penetration of mobile technology. But if you use the right metrics, which for many political reasons Google decided not to use, you can see, which are the richer countries and which are the less rich countries, right? By just looking how fancy phones they have and so on. And that kind of hiding real people behind numbers happens quite a lot. So, here's a couple of, we don't really need to care what's on this behind those numbers, but this is like maps and charts of, some well-being statistics in UK, in London. And if you focus on the map on the right, like, oh, these are the red areas where, people don't feel that well about their life, and then the green areas, the people who are more happy or more healthy. But this is all averages, right? This is completely forgetting about the individuals behind those numbers. And very often, a person or individual or it becomes just a statistics, right? And that's why we say here, like, data as real people, just data as a shape, or data as a space, but data as people, not just numbers. So we did a project in Brixton in London with their city council, and we tried to understand the needs of families living in overcrowded houses, and we designed a set of interviews, kind of running out of time, so I'll speed up. But the purpose of this project was, how can we create a feedback loop, so you're not becoming only a statistic by filling a questionnaire, but there's something the city can give you back as an individual, not only as an average or holistically as a community. So we designed this kind of chatbot interface that, by asking you a number of questions every day, would create a diary of your well-being, or so you can individually understand better what causes anxiety, or what issues do you have with paying bills, for example, or how is your stress level during the week. And that's aggregated data becomes valuable for the council there. But also, because we have this diary and we have this set of visualizations, you can kind of revisit your journey for the couple of weeks of the duration of the project, and kind of reflect on those factors and try to think, what can we do about this here. So in this way, we kind of, we did like an initial step of closing this loop. Like, you provide something to the city, but also the city, by providing this interface and this application and those mini visualizations, give you something back that is valuable and immediately useful. So I like to think of data visualization as an exploration of possibility space. So by allowing us to see a very deep dive view and very up from the sky view, we can move on these levels of abstraction and kind of attack the problem at different scales, or think of different solutions at different kind of granularity levels. And in the end, data and data visualization is just another way of understanding the world. Thank you.
Thank you, Marcin, for this very nice presentation. And I've got a question. What is the software used to generate these graphs?
Number of things, but it's mostly JavaScript or WebGL, so web technologies. So many of those things you've seen, they run on the web as well. And we have our own programming tool called Nodes that allows you to build that data flow graphs that transforms data into 3D visuals. Yeah, and so on this slide, there's my email if somebody has any more questions, I'm more happy to answer them after the talk. Yeah.
Okay, I've got a question. Did you use some data recorded from pilot plants from industry?
No. Like the closest things I could say we have used was kind of shipping, container shipping data from around the world and stuff like that. So transport data, not really chemical.
Okay, but we generate a lot of data.
I can imagine.
Maybe it could be interesting for you to connect with some participants or some people from chemical engineering.
Sure.
Any other question or comments?
Herman, you can ask for your question.
I can read it myself if I can. Marcin, who are your typical customers? And second question, do you have to do a new design for all of them?
So that's a good question. So in terms of typical customers, so I would say 60% is advertising agencies, and then 20% advertising agencies or big companies that also do it for advertising or marketing purposes. And then the remaining 40% is either startups or universities doing some kind of R&D research where they would have this data set and they want to come up with a new way of visualizing it, where they run out of ideas by using Tableau or Excel charts or something like that, and they want something interactive. And most of our works are bespoke, so made, to fit the purpose. But now because we have this notes tool, in theory, we could repurpose, some of the visualizations and plug in the data, because all those systems are dynamic. So if I swap CSV file, I'll get different visualization. If I swap Excel file, I'll get different visualizations. So that's the beauty of using code.
Okay. Other questions? No? No. So thank you very much, Marcin, for accepting, for giving this speech in this quite strange for you community of chemical engineering.
Yeah, I think vice versa, right? I mean, that's not something your community is exposed to day by day. But I hope it was a bit, inspirational at least, or eye-opening. Anyway.
Thank you very much.